Alright, class, now let's take a look at number 7 from our homework. This is from page 107. We're asked to find the derivative of the function of x when the function of x is defined to be radical x plus 1 at this particular a value. We'll do that at the end. We'll find the derivative of this function first, and then we'll substitute a in place of x. Or you could do vice versa. You could plug in a for your a first into the definition of the derivative and then evaluate from simplify from there. Okay, but we're also told to use the alternate definition instead of our difference quotient formula. So we're using this. Okay, so now how would I apply this to this particular function? You will rewrite this. Okay, rewrite this definition of the derivative, alternate definition, by using radical x plus 1, subtract radical a plus 1 all over x minus a, and then just like the example 2 that you've seen, we have to rationalize the numerator. Okay, what that means is I have to multiply the numerator by, you could think of it as its conjugate, radical x plus 1, but plus radical a plus 1 to cancel out the middle terms. Okay, all over the same thing, radical x plus 1 plus radical the square root of a plus 1. And then in turn, that becomes, let's see, so when we FOIL that, radical x plus 1 times radical x plus 1, that would just become x plus 1. So we got that. So, okay, when we multiply this by this, we get x plus 1. Okay, next we have radical x plus 1 times radical a plus 1. Oh my gosh, I don't think I have space for that. Okay, so let me write it down here. So let me move all this down here. So plus radical a x plus 1 multiplied by radical a plus 1. That just becomes radical x plus 1 times a plus 1, but you don't have to simplify the inside, as you will see. Next, we have to multiply negative radical a plus 1 by radical x plus 1. So that becomes negative times positive. That's negative right there. So negative radical x plus 1 times a plus 1. And then finally, I have to multiply out negative radical a plus 1 by radical a plus 1. And that gives me, again, negative times positive gives me negative. Results, radical a plus 1 times radical a plus 1 becomes a plus 1. But be careful with this, because that a plus 1 is still grouped together. Okay, before you take the negative, before you subtract that result. All over, oh my goodness, x minus a times the square root of x plus 1 plus the square root of a plus 1. So what happens here? Okay, so instantly I see that the first good thing I see is that the radicals cancel out, the big radicals. Oops. So this one cancels out with this one right here. And then I also see that the 1 right here, positive 1, will cancel out with this one, because in turn that will be negative 1 following the subtraction sign. And then so after all that, it appears that on the numerator I have x minus a, and on the denominator I still have x minus a multiplied by the square root of x plus 1 plus the square root of a plus 1. And we're still finding the limit of this as the x value approaches a. And then as you can see, I could cross out the x minus a's. So your question becomes this. This is still the same expression or equivalent expression as what you started with. Okay, just the conditions for the domain changes. But again, in terms of derivatives or continuity, okay, in terms of the limits, we're dealing with limits. It doesn't change. Okay, the equivalent, you could use the equivalent expression to find the same limits. And in turn, now your final answer becomes 1 over. Now I could substitute a in place of x. So you have 1 over a plus 1, radical a plus 1. Plus radical a plus 1 on the bottom. So you have 2 of them. So your final answer becomes radical 1 over 2 times the square root of a plus 1. And then for all x, you could substitute x in place of a. But for this question, we're substituting 3, the number value 3 in place of a. So your final answer becomes 1 over 2 times the radical 3 plus 1, which just becomes 1 over 2 times 2, which is 1 over 4. That will be your final answer for number 7.